Ladies and gentlemen, boys and girls, children of all ages. All right, tomorrow we have the test. Today, you have a review. I'm going to go over one question from the test and a couple questions from the review. I'm recording it. I'm going to post it on the TubeofView. I'm doing that in each of my 3 classes. Different problems each time, because that's the way I roll. And I want you to know how to do this stuff. I don't want any low grades, since progress reports come out Friday. Don't want any low grades and upset parents. I don't want to ruin a weekend. For some of you, I don't want to ruin a weekend. Some of you, I'll be like, I know, he is rude, isn't he?
Isn't it 17?
All right, yes. This problem is off the test for tomorrow.
It's on?
It is on the test for tomorrow. I took it directly off that. The model represents which expression? So now we have 8 circles, and each circle has been divided into 4 parts. 8 circles divided into 4 parts. Well, all of these problems have 8 in them, and they're all division. So let's eliminate some before we get going here. Let's eliminate some. Paul, is there one you see that we could eliminate?
There's 2, but yeah.
Okay, tell me one of them.
C.
Why?
Because there is 8 holes, but there isn't a half. There isn't one half.
Good.
It's 4 halves.
There are no halves. There are no halves. So we can eliminate that already. Eliminate that already. Hey, Zoe, do you see any others that we can eliminate?
You can eliminate A.
A, why?
Because you're not dividing 1/4 by 8. You're dividing something else.
Okay.
I disagree.
I know you always disagree, but just like
He does.
if we were dividing 1/4 by 8, we would only have one shape. If you're dividing the fraction first, which is the one Zoe said is eliminated, and she's right, that would mean we're taking each fourth and dividing it into 8s. 1, 2, 3, 4, 7. That is 1/4 divided by 8. Of course, I'd have to keep going on the other side too. If you have multiple shapes that are being divided, it's always going to be the whole number being divided. Our 8 circles are being divided into fourths. Our 8 circles are being divided into fourths. We don't have any fourths being divided into 8. We don't have any fourths being divided into 8. We have 8 wholes being divided into 4. And remember what we said yesterday. When we're dividing by a unit fraction. Eden, what's a unit fraction?
Unit fraction is...
Let's say this is a unit fraction. This is a unit fraction. This is a unit fraction.
It's 1 and
The 1 is the
denominator.
numerator. Excellent.
Numerator, yeah.
The 1 is the numerator. Unit means 1. So 1 out of 18. 1 out of 23. 1 out of 45. So if we're dividing, if we have the unit fraction first, our answer is going to be a fraction. If we have the whole number first, our answer is going to be the whole number. And our answer in this case would be 32. How would I get the 32? I'd count. And I'd count each part. Matthew.
So another way you can find that answer is by counting the numbers like that you just did in the circles,
Mm-hmm.
and then seeing which divides into that.
Yes. We could say there are 32 total fourths, because we're dividing the 8 circles into fourths. The 8 circles into fourths. All right, so that one's off the test. You'll see it tomorrow. Or tonight if you do the test because I emailed it home.
Yep.
Or last night if you do the test because I emailed it home. I know other students around the world, I know you wish you had me as a teacher, because what teacher emails the test home so they can work on it and get help or whatever they need? What kind of teacher does that? What a lunatic teacher is. Riley.
When either the person, if they were watching this video, either live in a country that has their first language is English, or go to a bilingual school.
No idea.
They changed
No
it.
idea.
They have it.
All right, on our review, we're going to look at whatever problem this is. The problem is 3/6 plus 3/8. 3/6 plus 3/8. Now, Phoenix, let me ask you a question. The way this problem is currently written, can we solve it?
No,
Why not?
they don't have the same denominator.
They do not have the same denominator. When you're adding and subtracting fractions, you must, and I mean must, have the same denominator. You must. Also on your review paper, the problem is written horizontally. When adding and subtracting fractions, you want to write it vertically because it makes it easier for us to change once we find the common denominator. Now I know what Nathan's going to tell me. Nathan is going to tell me I could change 3/6 to 1/2. That's what Nathan was going to tell me. Even if he doesn't know he was going to tell me that, that's what he was going to tell me. And you could. But Nathan, there's a reason I'm not going to do that in this case. It's because I want to remind everyone how to find the least common denominator so that they have it in their repertoire for later.
Wait, what?
So we're going to find the least common denominator. Eric, what are my denominators in this problem?
6 and 8.
6 and 8. And basically, what you're doing is making a multiplication table of 6 and 8. That's what you're doing. Multiplication table of 6 and 8. Now you have one in your journal, which you will be allowed to use on the test, so you could always look at that. But we make our multiplication table 6, 12, 18, 24, 30, 8, 16, 24. Booyah! I have found my least common denominator. It is 24. It is the first number that shows up in both lists. It is the first multiple that shows up in both lists. That makes it the least multiple, the least common multiple they have. Okay? I want to show this. So I know there are other ways, but you need to know how to do this. So now, I noticed some students were just changing 3/6 to 3/24. And let's think about that for a moment. If I gave you a test, let's say I gave Paul a test that had 6 problems on it, and he got 3 of them correct. What grade would you have, Paul? 50. Okay? And let's say I gave Eric a test, and it had 24 problems on it, and you only got 3 of them correct. Do you think your grade would be a 50? No. That would mean that if I put a 3 as my numerator, those 2 fractions are not going to be equal. We don't want that. No, we don't want that. So, as we've talked about before, when we are trying to find equivalent fractions so that we can make a common denominator, we can't change the value. just like Nathan was going to tell me that 3/6 is the same as 1/2, we need to change 3/6 into something over 24. Most of you, it's like, boom, I got it right now. It's very easy. But in an effort to teach some students how to multiply fractions, we're going to talk about it again. Okay, good. Now we have to ask ourselves, we need to multiply by 1, because if I multiply something by 1, it doesn't change the value. Doesn't change the value. So we have to ask ourselves, 6 times what is 24? Oh, wait. I don't have to ask myself. 6 times 1, 2, 3, 4 is 24. I know 6 times 4 is 24. In order for a fraction to equal 1, it has to have the same numerator as denominator. Riley, you checking this on your paper? This is one of the ones from the review we're doing. So in order to make this fraction multiple by 1, our fraction has to be 4 over 4. 3 times 4 is 12. If we notice, 3 is half of 6, and 12 is half of 24. So those fractions both equal 24. As Phoenix told me, both fractions have to have the same denominator, but you can't change the value. So we have to multiply 3/8 by a fraction that equals 1. So I need to know 8 times what is 24? 1, 2, 3. 8 times 3 is 24. For that fraction to equal 1, it has to have the same numerator as it does denominator. And this is where we multiply fractions. When we multiply fractions, which are the questions on your paper, you multiply straight across. 8 times 3 is 24. 3 times 3 is 9. Now we pay close attention to the addition sign, because in your lives, sometimes you get addition and subtraction mixed up. We don't want to do that. No, 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 no. And when we add or subtract fractions, our denominator remains the same. So Erica, what is 12? What is the sum of 12 and 9? 21. Erica, can that fraction be simplified? It can. Well, in order to simplify it, we have to find the greatest common factor. All these things are notes in your journal. All of them. All of them. And if you don't have them, all these things are videos on the Tube of You channel. So, as Erica is going to help me, since Erica said these can both be, that they can simplify it. Erica, what are my factors of 21?
1, 21. 3, 7.
You are correct, that's it. But you want to know something cool, though, is I know my divisibility rules. And since 2 plus 1 equals 3, and 3 is a multiple of 3, I knew this was divisible by 3. All right, let's go with somebody else who's brilliant. Tatum, my factors of 24. Yes, you are brilliant, but I was calling somebody else that's brilliant. Tatum, my factors of 24.
1 and
Okay.
6 and 4.
Okay. 2 and 12. She knows 2 because it's an even number. Even numbers, all of them are factors, or all of them have 2 as a factor. But wait. What does 2 plus 4 equal, Tatum?
2 plus 4 equals
6. Is 6 a multiple of 3?
Yes.
Yes. So I know 3 times something is going to equal 24.
Oh, 8.
8. 3 times 8.
8 is 16.
Now, Erica, you told me that this was going to have a greatest common factor of something more than 1. So what is the greatest number that appears in both of these lists? 3. Boom.
Boom.
So 3 is our greatest common factor. Once we know the greatest common factor, we divide both the numerator and denominator by the greatest common factor. And Erica, 21 divided by 3 is? 7. Erica, 24 divided by 3 is? 8. So what this tells us is if Peyton took a test that had 24 problems and she got 21 correct, and Celise took a test that had 8 problems and she got 7 correct, they would both get the same grade. The same value. The same value. It's worth the same amount. It means each problem would be worth the same amount. 12.5% each problem. Alright, so that's adding and subtracting fractions. So let's please not forget how to do that. Well, yeah, but it's the same process. Instead of adding, you subtract the numerators once you find a common denominator. Let's take, we're going to do 1/7 divided by 4. Now, Eden, you told me a unit fraction is what?
1.
Has a 1 as a numerator. If we're dividing a unit fraction and a whole number, if the unit fraction is the dividend, that means my answer is going to be a fraction. If the whole number is the dividend, or the first number, then my answer will be a whole number. So I know my answer has to be a fraction here. So Caden, what's my first step?
I do it different. I do it a different way. I don't have it.
Yeah, but if you do it on a test and it says, what equation does this problem represent? So you have to know how to do it this way too. All right, Sanaya, tell me what to do first. Good. I'm going to divide this into 7 equal parts. 1, 2, 3, 4, 5, 6. Awesome. Divided it into 7 equal parts. And then I'm going to divide each one of those into 4 equal parts. So now each one of these shapes is the same size. Just if you can't tell that, just squint your eyes a little bit or something. Because ideally they're the same size. Now what else, Sanaya? Obviously my numerator's 1, because I'm only talking about one little piece. One little piece out of how many? This is 7 across. This is 4 down. So if you think of it as an array, 7 times 4 is? 28. 28. Now if we talk about the standard algorithm, which is what you use, right, Caden? The standard algorithm? Okay, so if we talked with the standard algorithm, we'd have keep, change, flip. We'd keep our first fraction the same, 1/7. We'd change division to multiplication, and we'd flip the 4 over. What do you mean? You make it an H? No. The fraction 4 is actually the same as, the whole number 4 is actually the same as 4 over 1. So I flip that over. I get 1 over 4, which would equal 1 over 28. 1 over 28. Now the test tomorrow is going to be, it's going to have these skills on it, but it's going to have words in the problems. So you have to determine what skill to use. So you have to think. Thinking? That's just ridiculous. We haven't learned to think yet. I don't care. You're learning now. You can do it. If you get stuck on a problem, this is what I want you to ask yourself. In your head, quietly. I don't want you to yell it out. But if you're stuck on a problem, I want you to close your eyes and you put your fingers to your head like this and you ask yourself, what would Taylor do?
yes.
What would Taylor do? And it should pop into your head, this is what would Taylor do, so this is what I should do.
She would get it right. That's what Taylor did.
Riley has another suggestion.
Or you could yell, I can't do it.
No, that's a bad suggestion. Boom, shakalaka, peace out, God bless, love you. Sonic, sponsor me. Do something kind, subscribe now!